This is RD Sharma solution. MCQ we are taking for chapter 3 binary operations. The first one is, if A star B equals A squared plus B squared, then the value of 4 star 5 star 3. Now this question and the fifth question are exactly same. So we are doing this 4 star 5 star 3. So 4 5 star is A square plus B square. So 4 square plus 5 square. In place of A you will put 4. In place of B you will put 5. So 4 square plus 5 square. First we'll do this. 4 4s are 16. And then we have 5 5s are 25. So 16 plus 25. That will be the first value. Then you have to operate this with the another value which is 3. So this is 16 plus 25. Okay, that will be 41. So 25 plus 16 is 41. Now this 4 star 5 is 41 now. So we have to operate 41 with 3. So that will be again A squared plus B squared. That is 41 square plus 3 square. 3 square. So the answer is C. Please remember this one and fifth question are exactly similar in my addition. Question number 2. If A star B denote the bigger among A and B, and A dot B is also given. A dot B is equal to A star B plus 3. Then we have to find out 4.7. So this will be, see, 4.7. A dot B is what? A dot B equals A star B plus 3. So 4.7 will be 4 star, there is 4 operation with 7, and then we add 3. But what is the operation? It is clear given that A star B denote the bigger among A and B. So which one is bigger, 4 and 7? 7 is the bigger one. So just write 7 here and then add it with 3. So what do you get? You get 10. This is C. Question number 3. On the power set P of a non-empty set A, we define an operation this triangle by X triangle Y equals. So we have to understand that this question is more related to set theory. Set theory. So all these operations, all these commutativity and associativity and the identity, all these are being asked here one by one. Commutative, associative, not commutative, not associative, not identity. All these options are there. So we'll do one by one. First we'll do with the commutative part, then the associative part, and then the identity part. So what is the expression? Let me write it here. X triangle Y is equal to X bar. That is the complement. That is all the value which are not there in X. This is X complement. For example, complement of 1 is 0. 0 complement is 1, like that. So X complement intersection Y, or X bar intersection Y union X intersection Y bar. Okay. So we have to write X triangle Y, and if it is equal to Y triangle X, that is, if X and Y operated and Y and X operated, if they are similar, then we can say that it is commutative. That is A star B, if it is equal to B star A, then it is commutative. So what is Y star X, Y star or Y triangle X? Just replace X by Y. So Y bar intersection X union. Now just put X as Y and Y as X. So Y intersection X bar. Now you see the first term and the first term is equal to the second term in this second line. The second term in the first line is equal to the first term in the second line. Okay. Just we need to rearrange them. The second part, if we rearrange them, it will be exactly similar to the first one. That is, this is Y intersection X bar. I am shifting it, and I can shift x bar and y also, because x bar intersection y is equal to y intersection x. I am saying A intersection B and B intersection A. It's almost similar. B intersection C intersection B is equal. They won't change. So you can just change the position. That is why I change the position of x complement and y. Okay. Now this also I have changed x intersection y bar. You can always write that. And in between you have union already. So A union B is equal to B union A. So what do we get is, just by some rearrangement, the first one is exactly similar to the second one, right? That is why this is commutative. Yes. Now coming to the associative part, commutative we have already done. So x triangle y, you have to introduce z also. So x triangle y triangle z, if it is equal to x triangle y triangle z, first we operate x and y, then we operate y and z. Now if I start writing it, because it is a bigger expression, it will not be feasible or advisable to do it right there. Better is to make, because this is a set, power set P of non-empty set A. If I make x and y as these two set, so x complement intersection y is what? That is, whichever thing is not in x, just intersect it with y, so this will be the area. Now whichever thing is not in y, intersect it with x. What do you get? X and y. So x and y and x, when you intersect, this is the result. So from this commutative also you can show. This is commutative. Okay. Now same logic, same reasoning we are going to use it to prove that it is associative. This is x, this is y, and this one is z. So x, y, z. You can take any of them as x, y, z. Now x and y, just see the left area. That is the left figure which I just made. So the interlinking or the intersection part will not be taken. Will not be taken. But when we intersect it with y, say x and z we have taken, and when we intersect it with y, the intersection part will not be taken. So only this particular part which is inside, which I am saying, the intersection of all these three will be taken. So you take in any order, x, y operated with, first you operate x, y, then operate with z, first you operate y and z, then operate with x, or first you take x and z, then operate with y. Every time this commutative part will come, center part will always be there, right? So coming to now identity. Identity exists. Why? Because every power set has phi always inside it. Phi is null. That is this null phi. Okay. It is not empty, because a set with phi will always have something which is null. So A star E, if at all we get A back, then we say that E is our identity element, and that is what we have to find out. If at all we take this set A, or you can say an element of A, and we operate it with this phi, or phi we operated with A, and if we get A back, then that value will be, that phi will be a null set or null value or an identity value. So let us just prove that phi is a null value or not. If I write A operation Q, I will have to write x bar intersection y union x intersection y bar. Then in place of x write A, in place of y just write phi. So anything intersection with phi will always be phi, and anything any set, the phi null, phi is nothing, and if you take the complement, it is nothing but everything. And when you intersect it with A set, A will come. So A will come here. So phi union A, if you take the union, A will come. Okay. So this A is coming. So when we operate A with phi, A is coming back. That is why phi is our identity. And the answer is associative, commutative, and identity. D. Next is, if the binary operation star on Z is defined by A star B equals a squared minus b squared plus ab plus 4. A square minus b square plus ab plus 4. So we have to find out 2 star 3 star 4. The 2 star 3 first we'll do 2 square minus 3 square plus 2 into 3 plus 4. This is 4 minus 9 plus 6 plus 4. So you have this 10, 14 minus 9, which is going to be 5. Now 2 star 3 is 5. We will operate 5 with 4 now. 5 star 4. So in place of A, take 5. In place of B, take 4. So 5 square minus 4 square plus 5 into 4 plus 4. This is 25 minus 16 plus 20 plus 4. And the final value will be 33. Next is, if A star B equals A square plus B square, then the value of 4 star 5 n star 3. Now in my addition, the first question and fifth question are exactly similar. Okay, so I'm going to skip this question, but let me reiterate that the part C is the answer. The C option is the correct answer. It is similar to the first one. Just refer to that question. Sixth is, if a binary operation star is defined on the set Z of integer as A star B equals 3A minus B, then the value of 2 star 3 star 4 is. First we'll do 2 star 3. What is A star B? 3A minus B. So in place of A put 2, in place of B put 3. So 2 star 3 is 3 into 2 minus 3. So 6 minus 3 is 3. This is 3. Now 3 star 4 again, in place of A put 3, in place of B put 4. So 3 into 3 minus 4, 9 minus 4 is 5. Now seventh one, Q plus. This is denoting the set of all positive rational numbers. There will be no negative P by Q form. If the binary operation A, O minus, I don't know what it is written on Q plus, is defined as, now we are interested in operation this, A operation B is equal to AB by 2. So we have to find out the inverse of 3 inverse. So in order to find out the inverse, first we have to find out the identity element. What is the identity element? When you operate any value A with that identity element, A should come back. So I'm just using star for it, okay? It is same star and this symbol. So A star E is equal to A. What is A star E? It is AB by 2. So A into E by 2, right? So A into E by 2, what do you get? The E identity element as 2. Now we have to find out the inverse. So what do we operate with 3 so that we get 2? Okay. So A star B is equal to E. B is the inverse of A because we are getting the identity element. So 3 star B is equal to 2. So 3 star B is what? It is 3 into B by 2. I'll just change it. It is 3 into B by 2 and then it is equal to 2. I'll just change it because A star B or A operation B is AB by 2. It is 3B by 2. So 2 to the 4 and divided by 3. So B is 4 by 3 is the inverse of 3. Question number 8. If G is the set of all matrices of the form X, 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 all the elements are same, where X belongs to R minus 0. So you have to take the real number, but you cannot take 0. Then the identity element with respect to the multiplication of matrices as binary operation is. Okay. So identity element we have to find out. Identity element is when you operate this, what is given, with any element that should also belong to this set, the same element should come back. So we'll apply this identity element. We normally write it with E. So E. Why we are writing 4E? Because it is also belonging to that same matrix form. So the first row and the first column, x into E plus x into E. So this, you see, if you take the first row with first row with second column, it's going to give me the same result. Same with the second row with the first column, second row with the second column. Same value we are going to get every time, x into E plus x into E. That is 2xe or 2ex, you can say. So 2xe, here also 2xe, here also 2xe, here also 2xe, and this you equate with x. Now just equate them. 2xe equate with x. So what do you get? 2xe equals x. So here E is equal to x gets cancelled. E is 1 by 2. This 1 by 2 is not 0. So what will be the final result? The final result is option C, which is just replace x by half. Half and half. 1 by 2, 1 by 2, 1 by 2, 1 by 2. So C is the correct answer. This is the answer. Question number 9. Q plus is the set of all positive rational numbers with the binary operation star defined by a star b equals ab by 2 for all a and b belongs to Q plus. The inverse of an element a belonging to Q plus. Basically, we have to find out the identity element. Because the operation is given as a star b is equal to a multiplied by b by 2. Okay. So for identity element, if you multiply or operate a with e, it should give you a. Now what is a star e? It is ab by 2. So ae by 2. In place of b, just put e. So e, what do you get? E equals 2. Now we have to find out the inverse of a. So a operated with certain value, which is the inverse, let us call it as b. It should give you the identity element, which is 2. So ab by 2 is 2. B, basically B is the inverse of A. What will be B? It will be 4 by A. The answer is D. Question number 10 here. If the binary operation is defined on the set Q plus of all positive rational numbers by, how it is defined? A operation B is equal to AB by 4. Then you have to find out 3 operation, 1 by 5 operation, 1 by 2, 1 by 5 and 1 by 2 is what we have to do first. I'll use this star for the operation, okay. So A star B is given by B by 4, 3 star 1 by 5 star 1 by 2, 1 by 5 and 1 by 2 we have to operate. What do you get? It is AB by 4. So 1 by 5 into 1 by 2 divided by 4. This get 1 by 5 to the 10, 10 into 4 is 40. So 1 by 40 is the result of 1 by 5 operated with 1 by 2. Now we have to operate 3 with 1 by 40. So 3 operated with 1 by 40 divided by 4. So 4 for 16. This goes down. 3 by 160. This A is the correct answer. Question number 11. Let star be the binary operation defined on set Q minus 1. That is, you cannot take 1. By the rule A star B equals A plus B minus AB, then the identity element for star is. Okay. So in place of A star E is equal to A, that is what, because the identity element we have to find out, just put A as A, B as E. And this has to be equal to A. A gets cancelled, you can take E common here. And when you take E common, it will be 1 by 1 minus A inside. That is, if you take A on the right hand side, A minus A will be 0. E minus AE equals 0. Now you take E as common, 1 minus A equals 0. So this gives you two conditions. Either E is 0 or 1 minus A is equal to 0. But if you take the second condition, 1 minus A equals 0, that is A equals 1. But it is not possible. So E has to be 0. So identity element is 0. Question number 12. Which of the following is true? Star defined by A star B, A plus B by 2 is binary operation on Z. Then second part is binary operation on Q. All binary commutative operation are associative. Subtraction is a binary operation on N. So there is no similarity or some interconnection between all these four parts. They are entirely different. Though first and second part are somewhat related. So we have to take one by one. First one is Z, 1Z. Z is what? Integer. So it is said that star defined by A star B is A plus B by 2. This is a binary operation on Z. A star B is A plus B by 2. Okay. A is coming from Z, B is coming from Z. A plus B by 2. This is a binary operation on Z. Z will be what? Z is actually the integer. So we have, this is the set. Now rather than proving it, let us take some value. Take A as 1, B as 2. What do we get? A plus B by 2 is 1 plus 2 by 2, that is 3 by 2. And this 3 by 2 is not belonging to this Z. It is not belonging to this Z. So this is false. First one is false. 3 by 2 is not integer. So we'll take one by one. I am saying one by one. Right? Now in the second part, what we see, star defined by A star B is A plus B by 2 is a binary operation on Q. While doing this, we came to know that the value is coming as 3 by 2. So why not to take A and B again, 1 and 2? Because 1 by 1 is also in Q, 2 by 1 is also in Q. So 1, 2 you can take, and you can just say 3 by 2 is belonging to a rational number. So this is true. Or rather, you can take any other number like 3 by 2 or 5 by 2, and you just add them, you'll get some 7 by 6. And that is also a part of Q. That is the rational number. So the second part is true. A is false, B is true. Now coming to the third part. All binary commutative operations are associative. So for this, we will use an example that we have already done in our exercise number 1 and 2. That is, a binary operations are, all binary commutative operations are associative. That is, a binary operation which is commutative is also associative. This we have to prove or unprove. So we'll take a binary operation and we'll just call it as 2 raise AB. Okay. Now 2 raise AB, B star A is what? A star B, B star A, if they are equal, that means it is commutative. So 2 raise AB is A star B, B star A is 2 raise BA. They are almost they are similar because A into B is B into A. So this is commutative. But if it is commutative, whether it is associative or not, that we have to see. So A star B star C and A star B star C, let us equate. When we'll do first AB and then we'll do BC first. So AB is 2 raise AB and star C. Now you take 2 and all these two take to the power. That is 2 raise AB into C. Right? Here what we do? B and C has to be taken to the power of 2. So 2 raise BC. Now we have to take A and 2 raise BC to the power of 2. When you do this, 2 raise A dot 2 raise BC. Are they two similar? No, they are not similar. Okay, coming to the final part, which is the D part. Subtraction is a binary operation on N. N is a natural number. A natural number is what? You can count. 0 is not involved. The natural number is 1, 2, 3, 4 and it goes up to infinity. So subtraction is a binary operation. Let us check whether it is or not. Or just take an example. Rather, I'll take 2 and 4 and 4 and 2. So when we take 2 and 4, I'm saying subtraction is a binary operation. So operation is negative, subtraction. So 2 minus 4 and 4 minus 2. 2 minus 4 is negative 2. 4 minus 2 is positive 2. Positive 2 is belonging to a natural number. But negative 2 is not belonging to the natural number. That is why the subtraction is not a binary operation on a natural number. Hence this D part is false. So which of the following is true? Only the second part, B, is true. Rest all are false. Okay, this question we will take in the next discussion. Till then, thank you so much. Take care of yourself.